Welcome to the project demonstration of dual axis solar tracker system along with environmental parameters monitoring through IoT. So in this project we have added the IoT feature to monitor the sensor parameters like environmental parameters like rain in percentage and humidity in percentage and temperature in degree centigrade. These three parameters continuously upload to the Thingspeak cloud platform and we can access that data from anywhere in the world, and as well as the whole system getting power supply from the 12 volt 1 amp battery which is rechargeable, and that will get the power supply from this 12 volt solar panel directly, and the position of the solar panel will be controlled with the help of two DC motors. One is for x-axis and another is for y-axis, which we attached underneath this. So this is a 12 volt 1 amp battery. So here we are providing two way of charges. One is from solar panel and another is from the transformer. If the sunlight is not available during the night time, if you want to charge a battery, just connect this cable to the 230 volts AC input, and we need to connect the transformer. So see it clearly. So this is a transformer T at this T or S slot. So when you want to charge a battery from the transformer. So if you want to charge a battery with solar panel, disconnect that and connect this solar panel output directly at this slot. Right. So now the battery is charging with the help of solar panel, and after that, so when we are on the switch, so clearly see that there is a switch here. So this is the switch on off. Right. So when we on that, so the 5 volts output will be given as input. 12 volts output is given as input to this PIC microcontroller, PIC 16F72 microcontroller. With the help of this, we are going to do the solar tracking system by getting input from these 4 LDRs. 2 LDRs for east and west deviation and another 2 LDRs for north deviation. So during winter time, the sun will deviate towards the south direction, so that in order to detect that position when it deviate to the south. Right. So during the winter, when the sun deviates towards the south direction, that will be identified by these 2 LDRs, and for that purpose we are making use of another extra DC motor which was attached to this total platform, so that will be controlled in Y direction. So here the 2 DC motors are 12 volt 3.5 rpm DC motors with 3.5 rotations per minute, so that it can control the like solar panel when the sun is moving in a slow motion. So here before on the gate, we need to provide the internet service to the system to upload the data to Thingspeak. So for that we need to on the hotspot in your phone. So go to hotspot settings in your phone and change the hotspot name to project 5H35. So without any space, without any capital letter, and the next password should be 123456789 and AP band should be 2.4 gigahertz. After that, on the data and on the hotspot and log into the Thingspeak cloud platform. So click on this. So there we get the data. So this is the old data which we have already uploaded, that is humidity, temperature and rain percentage. So now you can on the system. So when we on the power supply to this, so the solar panel will be go to the 0 position, and then we are placing a light on this LDRs. So it will start moving. So when it's set to the west side, then automatically the 2 DC motors will rotate that till the limit switches. There we place the 2 limit switches for X motion and Y motion. There is another limit switch was placed on this one. So coming to the interfacing connections, we have interfaced these 3 limit switches at pin number C5, C6, C7 of our PIC microcontroller. Right. And 2 DC motors interfaced through the L293D motor driver. So that was interfaced at C0, C1, C2, C3 pins. and these 4 LDRs interface at the A0, A1, A2, A3 pins directly. So when it touches the limit switch, then automatically it will start moving towards the east side. And we can see the data is also uploading to the Thingspeak. So we are getting data. So if you want to get the fresh data in this platform, so you can download that. Go to data import export, download the data. So here we can see that. Now here we can see the date and time and how many samples till now collected. So the first one is humidity, temperature and rain level. So just let me pour some water on that. Right. And after you downloaded this data, you can now erase the data. So to erase that, data import export to download channel settings to erase the data. In that only do clear channel. Right, channel got cleared. Now go to private view to access the live graph data. So the data will be uploaded to the Thingspeak cloud platform at a duration of 15 seconds maximum time. So based on your network speed, it will be uploaded into that. So for this data to be uploaded, we are making use of this Arduino Uno. So why? Because on this PIC microcontroller, the limited pins are already utilized for the so-called input and output. So now we are utilizing that Arduino for upload the data to the Thingspeak from the ESP8266 Wi-Fi module. So we are getting the data now. So the rain data is 68. So here we have interface this rain sensor at A0 pin and DST11 at pin number 10 and 8 and 9 to this ESP8266. So this is the ESP8266 which I interfaced to the Arduino Uno board directly. So the whole system getting power supply from this 12 volt 1 amp battery directly. So this is the north deviation.